Hi guys, welcome to another test paper written by my grade 10s. I think they wrote it today, yes. We're going to go through this test paper. This paper is supposed to be answered in about 1 hour 30 minutes. It contains a lot of questions, but I know they are very good students, so they'll be able to do that under pressure. It's a paper 2, which implies that we can use a calculator. I'll try as much as possible to finish up. I doubt if I can finish up everything in 1 hour. Sorry, everything in 30 minutes. My videos are basically 30 minutes to 35 minutes long. If I don't finish up the entire question in 30 minutes, there will be several parts to this video. So let's see that this is part 1. That is if I can finish up everything. The paper is on polynomials and I think, basically polynomials. And quadratic is part of polynomials, so generally polynomials. Let's start very fast. Since you can use a calculator, some of the questions would easily use a calculator for. And the first question is a quadratic inequality. Let's see, the total score for this paper is 68 marks. And we should be able to get at least 80% out of this. So 68 marks, the first question is a quadratic inequality. So we solve it like we solve a normal quadratic equation. Since we are using a calculator, we should be very, very smart about whatever we are doing. So we're going to use a calculator to solve this question. 19x minus 5 is less than 0. Because, again, I'm using a calculator, we can just use a class-based calculator for this. I think the other calculators can't do. This calculator won't be able to solve the inequality, but the class-based calculator can solve. So we're using a class-based calculator. So toggle to quadratic inequalities, that is B. So B, and this is it's a polynomial of degree 2, and this is less than or equal to 0. So less than or equal to 0 is the fourth option. So I select the fourth option and I input my values. So 4x squared, then 19x, then negative 5. So this gives you x is in between negative 5 and 1 over 4. So x and 1 over 4. So this will give you at least 1 mark out of the 3 marks. But let's solve the question. We solve this like a regular quadratic equation. We need two numbers when multiplied, you get 20, but when summed up, you get 19. So 20. The factors of 20, we got 1 and 20, and the negative pair. So there's negative 20. So yeah, I think it's easy. The number over there will be 20 and negative 1. So we go 4x squared plus 20x minus x minus 5. This is less than or equal to 0. We can factor out 4x. This will give you x plus 5 if my math is correct. Then factor out negative 1. This gives you x plus 5. This less than or equal to 0. This then gives you 4x minus 1. Then x plus 5 is less than or equal to 0. And it is a positive quadratic curve, so the critical values will be x equal to 1 over 4 and x equal to negative 5. And since there's a positive quadratic curve, positive quadratic curves are smiles, like it looks like a smile. Anything positive will make a smile, so it's this way. And let me put the critical values on the number line. So this is negative 5, let me not forget. So this is negative 5 and this is 1 over 4. And we are looking at less than 0, so I'm interested in the portion of the graph that is below the x-axis. So I can say that x is in between negative 5 and 1 over 4. So just 3 marks is a cool chop, 3 marks. There is also a question that you can use a calculator for. I would advise you have a class-based calculator for the additional mathematics. It's going to save you a lot of work, or at least it can help you check most of your calculations. So again, this is quadratic polynomial sets for equations. So let me go back so that I do it again. Equations, that is A. Pardon me, I think my computer is a little bit glitchy. So yeah, A, and it's a polynomial of degree 2. We've got 1x squared, then 8x, then minus 9. So the x values are x equal to 1 and x equal to negative 9. and that's what I'm interested in. The minimum value of x is -4, and the minimum of y is -25. So x was equals -4 and x equals -25. So if you want to go backwards with this one, what you're going to do is you don't really touch that of the y. This is y, sorry. You don't touch that of the y, but you go backwards with the x. This is what I mean. This is x minus 4, so going backwards is the same as writing x plus 4. Then you square this in, then you keep the y the way it is. So this is pretty easy if you use a calculator. Again, using the calculator will get you a mark out of this. It wasn't so challenging. But let's assume that you didn't know how to use a calculator for. Or let's do one more question where you use a calculator. Let's take it that you did use a calculator and we got x, the minimum or maximum value of x to be equal to 7, and the minimum of y or maximum of y was equal to 9. Then we can say going backwards will be x minus 7 all squared plus 9. So we go backwards with the x, but we maintain the y. So that's just by the way. Let's solve the question. You get 1 mark, you can get a full mark anyway. Let me take this one off. Let's actually solve the question. So with this one, we've got x squared plus 8x minus 9. There are two ways of solving this question. We'll go through all the two ways. I prefer one way better, the completion of squares. So completion of squares, we've got x squared plus 8x. We need to create and destroy. We need to add half the coefficient of x. So there's 8. If I'm to add half of this, half of 8 is 4. So there's 4 squared. And I destroy the 4 squared so that we don't do any harm to the question. And that's -9. And the three things over here, we can factorize this one out to x plus 4 all squared. The way I can see this would be, this is squared and this also squared. So I bring the numbers without squared and square all of them. So that's one way to remember. And this is -16 minus 9 will be -25. We got it correct anyway with the calculator. So f of x is equal to x plus 4 all squared minus 25. Another 2 marks gone. So in total, 5 out of 68. That is fair enough. Now, use your answer in I. What do we get in I? Is it I? Yeah, BI. Okay. To find the value of x, the greatest value of x. Find the greatest value of whatever this is, and the x value at which it occurs. So, using the question, this question, I think it looks the same. The only difference is one is negative. Yeah, I think when I factor out -1, so we've got 9 minus 8x minus x squared. If you factor out -1, you should get 9 plus 8x, -9 plus 8x plus x squared. So let me rearrange it. So -1 is x squared plus 8x minus 9. Let's see if it matches. X squared plus 8x minus 9 is matches. Okay, and we got this one to be x squared, x plus 4 all squared minus 25. So let me just substitute that one over there. So -1, then I put this one over there since I'm to use it. Good. So expanding with the negative, this gives you negative x plus 4 all squared plus 25. So I can say that the greatest value, the reason why this is the greatest value because it's negative. X squared is negative. Negative would make you frown. So that's the greatest value, the maximum point actually. So the greatest value of y will be y is equal to 25, and it occurs when x is equal to -4. And again, if you want to check this answer, it's pretty easy. Let's use a calculator to do this. And okay, so please, yeah, my calculator is just glitching. Just bear with me. So x squared, -1 x squared minus 8x plus 9. Okay, so we are getting this one to be the x value is -4, just like we got, and the y value is +25. So yeah, we are right. So this question wasn't that complicated. Oh, we have to sketch the curve. We've done 9 minutes already. We're still on question number 1. We have to sketch the curve of this. So sketching the curve of this, we need the x-intercept. So x-intercept. We need the y-intercept. We need the turning point. then we need the orientation of the curve. Because this is negative, like I said earlier, it's going to look this way. Negative things makes us frown, so it's going to be a frown. Assuming it was positive, positive things makes us smile, so it's going to be the curve. So that's just by the way. X-intercept. For x-intercept, we say that y equals to 0. So let's go to the side. So this gives you 0 is equal to 9 minus 8x minus x squared. I think I already used a calculator to solve this. This was a question: x equals to 1 and x equals to negative 9. So x equals to 1 and x equals to negative 9. So there is going to be an intercept at negative 9, and there's going to be an intercept at 1. So the y-intercept would be, for y-intercept, x equals to 0. So anywhere you see x, you put 0 over there. So this gives you y equal to 9 minus 8 of 0 minus 0 squared. This will give you y to equal to 9. So the y-intercept is going to be 9. Let's assume it's somewhere here. I'm not so sure, but let's assume it's somewhere there. And the last one is a turning point, which we already calculated in the previous question. So that is negative 4, 25. So let's say this is my turning point, negative 4, 25. It's not going to scale anyway, so just bear with me. Okay, so this is how the curve is going to look like. Kind of, I'll readjust. Let me readjust it. It doesn't look nice. Okay, so there's a turning point. Then, okay, so this would be my 9, and this would be my 1. Okay, so that's for. Let me confirm the x-intercepts again. So that was 1 and negative 9. Yeah, we are good to go. So that answers this question, question number 1, and we've done 11 minutes into the video already. Yeah, but I think it was a cool question number 1. Question number 2. Again, there's a sketch we have to do. So for this sketch, step 1, we need to know the orientation of the curve, whether it's going to be this way or it's going to be this way. So for positive graphs, they point towards the positive y-axis. They point upwards. The last part of the graph points upwards. It points towards the positive y direction. And for negative graphs, it points downwards. It points towards the negative y-axis, because negative y-axis is down. So first we need to know the orientation of the curve, whether it's positive or negative. The next one we need to do is to find the intercept. So find x-intercept. Then we need to find y-intercept. And we don't need the turning point for this, since these are 10th graders doing this. They've got no knowledge on calculus for now, so we don't need the turning point for this. Let's know the orientation of the curve. To know the orientation of the curve is pretty easy. You multiply all the x's. So this is x, 2x, this is x, and there's negative x. So let's do 2x times x times negative x. And there is no number in front, so I would have multiplied the number 2. So this will give you negative 2x cubed. So there's a negative graph. So I know my graph is going to look like this. I don't know the answer, but I know definitely this is wrong, because my graph is going to look something like this. Okay, so now that I know the orientation of the curve, let me delete this one. It's a negative graph, so this should go off. This is what my graph is going to look like. Let's find the x-intercept. So for x-intercept, what we're going to do is to equate each bracket to 0. So I take this bracket, I equate it to 0. I take this bracket, also equate it to 0, and I take this bracket, equate it to 0. It's pretty easy. So let's start. So 2x minus 5 equals to 0. This will give you x to be equal to positive 5 over 2, which is approximately equal to, not approximate, it's actually exact, equal to 2.5. I'll use the decimals instead of the fraction. So I know there is an intercept at 2.5. Let's do the other one. Let me wipe off this. So x plus 3 equals to 0, x equals to negative 3. Then 1 minus x equals to 0, x equals to 1. So I know we got x-intercept at, so for x-intercept, we've got this one to 2.5. All of them are positive. Interesting. Oh, we've got negative 3. Let me arrange it well. So negative 3, 0. Then we've got another one, 2.50. Then we've got the last one, which is 1, 0. Then the last thing we need to find is the y-intercept. So for y-intercept, x equals to 0. So we replace all the x's we see with 0. So this will replace with a 0, this will replace with a 0, and this will replace with a 0, giving us this to work with. We've got y is equal to 0 minus 5, 0 plus 3, then 1 minus 0. So this is basically negative 5 times 3 times 1. This gives negative 15. So the y-intercept is going to be 0, negative 15. So we've got everything we need to solve or sketch the curve. I have two positive values. I like to sketch the curve before putting my values there because I already know the orientation of the curve. It's better to know the orientation. So I know the curve is going to look something like this. Yes, so let me put in my values. It's not so accurate, but let me put in my values. This is negative 3. Negative 3. The y-intercept was negative 15, so negative 15. This x-intercept was 1 comes before 2.5, so 1. And this is 2.5. This is not drawn to scale, but these are the most important things we need to see on the graph. So the first one, the x-intercept, we need to know the orientation. The orientation is basically multiplying the x values. X is you see over there, and any number outside the bracket. The next one is to find the x-intercept. X-intercept is to equate each bracket to 0 and solve for x, and y-intercept is to replace all the x values by 0 and multiply the rest to get uy. So that is just that. This is for 3 marks. Now the next part of the question says we should find, or we should solve the inequality where the function is less than 0. So the function less than 0 means that we are interested in below the x-axis. So this portion of the graph is below the x-axis, and this portion is also below the x-axis. In case you don't know how to do this, I would advise you expand everything, then you use a class-use calculator. And that is, if you don't know what to do, that is going to be a long shot, but it will still get you your answer anyway. Less than 0, we are looking for below the x-axis. So in this case, below the x-axis, we are in between negative 3 and positive 1. So we say that x is in between. This is how to write in between. So negative 3 and positive 1. This reads as x is greater than negative 3. At the same time, x is less than 1. Then the last one will be x is greater than or equal to 2.5. Okay. So that answers the question. And we're told to do the modulus of, okay, we have to do the modulus of this. Let me just copy everything, copy and paste. Let's go to be a digital teacher. Yes, you can literally copy and paste. So let me copy and paste. I've copied, let me paste it over here. So yeah, yes, okay. So because you are doing the modulus of this, it means some part of the graph shouldn't be there, like the graph below. So this is going to be this way. It's not symmetrical, but let's see. Yeah, let's assume it is. Then this side will go up. We can decide to clean everything over there, or use short dashes out clean. So I'll write this again. So this is 1, and that's negative 15, and that's 2.5. So this was 1, this was negative, this was 3, am I mistaken? 2.5, my bad. And this was negative 15, so it becomes positive 15. So there's the modulus they are talking about. If this is worrying you, you could literally use short dashes to represent the movement. So I don't like the short dashes. I prefer you just clean it up. Okay, so that answers that question again. We've done 19 minutes so far and 3 questions. And question number 2 questions. So question number 3, probably this is our last question since it looks like every question takes 10 minutes to solve. The polynomial p is such that p of x is equal to 6x cubed minus 35x squared plus 34x plus 45. Find p of x in the form 2x minus 5 q of x plus r, where q of x is a polynomial and r is a constant. There are lots of ways to go about this. I can first find the remainder, but I think it's a long process. What I'm going to do is I can see this is a quotient and there's remainder and there's a divisor. So I'm going to divide the polynomial by 2x minus 5. Yeah, please make sure you don't write the division sign this way, because there's long division, there's square root, and there's no long division, so you have to be very careful. There are several ways of doing this long division. We can use the synthetic method. I want to approve the synthetic method because this is 2x, it's not just x, so at times it becomes a little bit complicated. If you don't know the synthetic method and you want to know or you want to learn how to use the synthetic method, please leave it in the comments, and yeah, if I get about 3 or 4 people commenting on that, I would have to do a video on the synthetic method. That is actually easier to do long division. So that's 2x minus 5. So we've got 6x cubed divided by 2x. This is the same as me basically writing 6x divided by 2x. And this x cancels out, this 2 cancels out the 6, and now left with 3. 3 times xx gives you 3x squared. So there's 3x squared. This multiplies everything over here. If it multiplies this, I'll get 6x cubed minus 15x squared. Okay, so we do the subtraction, and 35. Please don't be shy to use a calculator for this one. Basic calculation. It's better that way so that you don't worry yourself with unnecessary errors. So this will give you negative 20. So negative 20x squared, and bring down the 34x. So 34x. Repeat the process again. So negative 20x squared is the same as writing. Okay, let me write it this way first. Negative 20xx divided by 2x. This cancels out, and this cancels out 10. So there's negative 10x. So negative 10x. This negative 10 multiplies everything, and this gives you negative. This gives you negative 20x squared. Then negative 10 times negative 5 will give you a positive 50x. So let's do this again. Okay, 34 minus 50. Again, like I told you, don't be shy to use a calculator. So that will give you negative 16. So negative 16x. Then I drop the 45. So 45. And negative 16 divided by 2x. This cancels this, and this gives you a negative 8. So negative 8 multiplies everything. This gives you negative 16x plus 40. Then if you do the subtraction, this is going to be 5. So we've gotten the quotient and we've gotten the remainder. But let's see if the remainder is correct, and let's check if the remainder is correct using the remainder theorem. Let me write this on the calculator. 6x cubed, at least you can check the answer before we move on, minus 35x squared plus 34x plus 45. Okay, so calc the divisor equated to 0 is going to be 5 on 2, which is 2.5. If this is correct, I should get the answer to be 5. So yeah, we are correct. So we can write this as 2x minus 5 multiplying q of x. Q of x is 3x squared minus 10x minus 8, and the remainder is 5. So that is p of x, and that ends the question for 3 marks. Now we have to express p of x minus 5 as a product of linear factors. We already know what p of x is, so let me just write p of x. So p of x is this, and I'm going to subtract 5 from this, and this cancels out, and this gives you 2x minus 5, then 3x squared minus 10x minus 8. We need to factor out this. Again, we are using a calculator, so this should be very easy. There's a quadratic equation. Let's solve the quadratic equation and go backwards, since we are using a calculator. If you are not using a calculator, we'd have to go through the entire method of solving the quadratic equation. So polynomials of degree 2, we've got 3, negative 10, and negative 8. So the answers are 4 and negative 2 over 3. So x equals to 4 and x equals to negative 2 over 3. So going backwards to give you x minus 4 equals to 0, and going backwards for this one to give you 3x, like multiply everything by 3 equals to negative 2. Let me take my time and do this one. Okay. I know some of you are not in my school, so let's take it. bit by bit. So x was equal to 4 and x is equal to negative 2 over 3. So going back also, this will give you x minus 4 equals to 0. And multiplying both sides by 3 to clear the denominator, that will give you 3x equal to negative 2. So x minus 4 is still equal to 0. Then this will give you 3x plus 2 equals to 0. Then this gives you x minus 4. Then 3x plus 2 equals to 0. Both of them equal to 0. Then this is the same as writing x, 3x plus 2. Then negative 4, distributing this one, 3x plus 2 equals to 0. Then this gives you 3x squared plus 2x minus 12x minus 8. So we can fit this one here. This is the part we are interested in. We are not interested in the equal to 0. So let me take this part and fit it over here. Okay, we are not interested in the equal to 0. Equal to 0. Then yeah, we are done. So we've got 2x minus 5. Then we have 2x minus 5. So that is the product of the three linear factors. By the way, if you want to solve this, you're looking for two numbers when multiplied, you get negative 24. When summed up, you get negative 10. Then the two numbers will be 2 and negative 12. So yeah, that's just another way to do it. 2 marks, we don't really need to waste our time when you can use a calculator. So again, we're told to find p of x equals to 5. So let me delete this one. Let me go for the p of x. So it means if the p of x is not so correct, it's going to be a little bit difficult for us to continue. Okay, so yeah, p of x is this. We're told that this is equal to 5. This goes to the other side. That will give you 2x minus 5. Then 3x squared minus 10x minus 8 equals to 0. 5 minus 5 is 0. But we already know that this thing over here was this thing over here. So let me just copy that and paste. Okay, so let me paste it over here. And this is equal to 0, which means that each bracket is equal to 0. 2x minus 5 equals to 0. X minus 4 equals to 0. Then 3x plus 2 equals to 0. This gives you x to be equal to 5 over 2. And x equals to 4. And x to be equal to negative 2 over 3. And that answers the question. 1 mark. Why is this 1 mark? I feel there is a shorter way to do this. Okay, by the way. Let's pause over here. We'll resume the video from question number 4. Bye bye for now. I've done 27 minutes. I don't want this video to be too lengthy.